Hello everyone. Now we will see about what is fiber optics, what are the properties of fiber optic cables, and what are the structure of cables, and what are the basic concepts that is related with this fiber optic phenomena. So this diagram shows the bundle of fiber which gives the emission of light. And what are the advantages of optical fiber? It is having immense bandwidth to utilize and total electrical isolation in the transmission medium, very low transmission loss, and it is very small size and lightweight, high signal security, very low power consumption, and wide scope of system expansion. What is an optical fiber? An optical fiber is a hair-thin cylindrical fiber of glass or any transparent dielectric medium. It may be made up of silicon dioxide or barium oxides like. The fiber which are used for optical communication or waveguides made of transparent dielectrics. So its function is to guide visible and infrared light over long distance. So this is the structure of optical fiber. At the center we are having a core which is having a very thin diameter. Surrounding that core we are having a cladding, and surrounding that cladding we are having a insulation coating to protect this optical fiber, and we are having a strength members like Kevlar membrane and outer jacket to protect the optical fiber. So core, it is a central tube of very thin size made up of optically transparent dielectric medium and carries the light from transmitter to receiver. The core diameter can vary from about 5 micrometer to 100 micrometer. And outer that core we are having a optical material that is called cladding. So the cladding is the outer optical material surrounding the core, having a reflecting index lower than that of core. It helps to keep the light within the core medium itself throughout the phenomenon of total internal reflection. And we are having a buffer coating to protect the fiber. It is nothing but a plastic coating that protects the fiber made of silicon rubber. The typical diameter of fiber after coating is about 250 to 300 micrometer. So this is the working principle of optical fiber communication, total internal reflection. When a ray of light travels from denser medium to rarer medium such that the angle of incidence is greater than the critical angle, the ray reflects back into the same medium. This phenomenon is called total internal reflection. If the optical fiber In the optical fiber, the rays undergo repeated total internal reflections until it emerges out of the fiber end, even if the fiber is bent. So this is called total internal reflection. So in the total internal reflection process, the light signals is confined within the optical fiber medium itself. That is, in between core and cladium, the light falls and it is again reflected back into the core medium itself in such a way that we are protecting the escaping of signals from this optical fiber. And this diagram shows how the light is propagated by this total internal reflection in this optical fiber. The first diagram shows that we are having a central core of refractive index N1 and the cladding of refractive index N2. Surrounding that we are having a air medium. So the refractive index of air medium is N0, it is about 1. And the light, when it moves from the core medium to cladding interface, and it is having an angle of incidence phi1 and the angle of refraction is phi2. When phi1 is less than phi2, what happens is that the light is refracted into the cladding and air medium. When phi1 is equal to phi2 and the angle of refraction is 90 degree, in that condition the ray propagates at the interface. And phi1 is greater than phi2. When the angle of incidence is greater than the angle of refraction, the light is totally internally reflected back into the core medium itself. So in this way, we are confining the light within the core medium itself by the principle of total internal reflection. So the principle of optical fiber communication is total internal reflection. What are the classification of fiber? The optical fiber is classified based on 3 criteria. One is the material. Based on the material it is fabricated, based on number of modes, based on refractive index profile. Based on material, it is classified into glass fiber and plastic fiber. Based on modes, it is classified into single mode fiber and multi-mode fiber. Based on refractive index profile, It is classified into step index fiber and graded index fiber. Now we will see about in detail about the classification of fiber. In glass fibers, we are having two categories. One is the plastic fiber and glass fiber. So the mixture of metal oxides and silica glasses are generally used to manufacture the fibers. So it is ultra pure and ultra transparent. Glass fiber optic cables has a low attenuation and comes at the higher cost. So we are using the combination. Suppose if you are taking a core of silicon dioxide and cladding is about silicon dioxide of the same and which is having a less refractive index. And if you are taking a core of germanium oxide with the silicon dioxide and cladding may be silicon dioxide in such a way that we have to maintain the condition that the refractive index of core should always be greater than that of refractive index of cladding. And in plastic fibers, they are made up of plastics, they are of low cost and they are having large numerical aperture and large acceptance angle. They have high attenuation. And if you are using a core is a polymethyl methacrylate and cladding may be a copolymer in such a way that we are maintaining the condition the refractive index of core should be greater than the refractive index of cladding. So based on material, we are classifying into glass fiber and plastic fiber. Based on mode, we are classifying the fibers into two categories, single mode and multi-mode fibers based on refractive index, step index optical fiber and graded index optical fibers. On the basis of number of modes, in a single mode fiber, only mode can propagate through the fiber. It has small core diameter and high cladding diameter, and difference between the refractive index of core and cladding is very small, and there is neither dispersion nor degradation. Therefore, it is suitable for long distance communication. The light has passed through the single mode fiber through laser diode. So mode means the path in which light propagates. So as it goes in a single path, it is called single mode fiber. In a multi-mode fiber, it allows large number of modes for light ray traveling through it. The core diameter is 40 micrometer and that of cladding is 70 micrometer. The refractive index difference is also large than single mode fiber. There is signal degradation due to multimode dispersion. It is not suitable for long distance communication due to large dispersion and attenuation of signals. So on the basis of refractive index, there are two types of optical fibers, step index fiber and graded index fiber. So in a step index fiber, the refractive index of core and cladding is constant. That means the refractive index varies like a step-like manner and it is throughout the fiber, it is constant. The light ray propagates through in the form of meridional rays which cross the fiber axis during every reflection at the core cladding boundary. In a graded index fiber, this type of fiber core has a non-uniform refractive index that gradually decreases from the center towards the core cladding interface. The cladding has a uniform refractive index. The light rays propagate through it in the form of helical rays. They never cross the fiber axis. So in a step index fiber, the refractive index varies like a step-like manner, whereas in the graded index fiber, the refractive index varies gradually from the center to the outwards in order to reduce the dispersion. So it has been constructed like that. And this is a diagram of step index multimode fiber. So multiple modes are propagated through the core. By the total internal reflection process, it is propagated. In a graded index fiber, the rays are moving in a core medium like a skew rays and it is moving in a helical path. Whereas in a step index fiber, it is moving like a meridional rays. And a multimode single mode light propagation, so it is moving in the zigzag manner, and it is a multimode graded index fiber, it is moving like a helical rays, and there is a self-focusing effect happening within the core medium itself because of the variation in the refractive index. Because of that, dispersion is reduced in the case of graded index fibers. And this is the difference between single mode and multi-mode fiber. So in a single mode fiber, as we have seen already, core diameter is about 5 to 10 micrometer, cladding diameter around 125 micrometer, and protective layer is about 250 to 1000 micrometers. And numerical aperture is about 0.08 to 0.1. Bandwidth is more than 50 megahertz per kilometers. In the case of multimode fiber, core diameter is 50 to 350 micrometer and cladding diameter 125 to 500 micrometer and protective layer is about 250 to 1100 micrometer and numerical aperture is 0.12 to 0.5 and bandwidth is less than 50 megahertz kilometer. In single mode fiber, only one mode can propagate through the fiber And the single mode fibers are of only step index fibers. It has smaller core diameter and the difference between the refractive index of core and cladding is very small. There is no dispersion, that is, there is no degradation of signal during propagation. Since the information transmission capacity is inversely proportional to dispersion, this type of fiber can carry information for longer distances. Launching of light and connecting of two fibers is very difficult because of its very low diameter, small diameters, and installation is also difficult as it is more costly. And whereas in a multi-mode, it allows large number of paths or modes for the light to propagate, and the multi-mode fibers are useful in manufacturing both step index and gradient index fiber. It has larger core diameter and refractive index difference is larger than the single mode fiber, and dispersion is more due to degradation of signal owing to multi-mode. Information can be carried to shorter distance only. Launching of light and also connecting two fibers are easy. Fabrication is also easy and installation cost is low. Thank you.